Baby, when they look up at the sky, we'll be
It started back in 1898 when William Ramsay and Morris Travers discovered neon gas. It was found that neon is an inert gas, meaning that it doesn't react with other elements because its valence shell is full. In every element, there are valence shells that need to be filled. If there are 8 valence electrons, the valence shell is full. For example, potassium has a charge of +1 because it's looking to lose an electron to gain noble gas stability. The point is that neon is really hard to react with because they are perfectly content with the numbers of electrons that they have.
Because they're inert, a lot of energy is needed to remove electrons from a neon atom. When neon lights are used, so much energy is present that the electrons in the highest energy level jump to another energy level, but then jump back down to release the energy in the form of photons in light. So, the first neon light that was made was called the Geissler tube, which was made by George Claude, which was only really used for scientific purposes. The very general explanation of how neon lights work is that neon gas is pumped into a sealed tube, and when a large amount of electric charge is passed through the tube, the gas glows. We will go into detail very soon.
So, what most of us see as this common trifling part of our daily lives actually have a lot of science and success behind it. Neon lights are used all around the world, lighting up the signs of Las Vegas or informing the public of open restaurants when they're going out with friends. This relatively modern discovery has become a massive industrial tool for many business owners.
So, like we said before, neon light is produced by sending a huge amount of voltage across the tube. By huge amount we mean 15,000 volts. The neon gas is pumped into a sealed tube with electrical terminals at either end of the neon tube. One end is negative and one end is positive. When the terminals are switched on, the neon atoms will start getting pulled apart. So, once the atoms begin to get pulled, they will lose electrons and become positively charged ions. So, the positively charged ions will be attracted to the negative side of the tube, and the electrons will be attracted to the positive side of the tube, since they are negatively charged. So, many collisions will be occurring that generate a sudden smash of energy. That will make the ions and atoms release the energy in the form of photons of light.
Neon gas isn't the only element that can be used to make neon lights. We don't want you to think that neon gas is the only gas that is used to make neon lights. Neon lights is just the general name. For example, mixtures of different gases can influence the color. Neon provides a clear red color. Neon gas with red phosphor provides a red opaque color. Phosphor with argon and mercury gas provide a blue, green, and yellow color. Helium gas provides a pinkish white color. Neon gas with yellow phosphor provides an orange color, and helium and yellow phosphor make yellow neon lights. As you can see, neon lights have a lot more to them than we originally thought.
This scientific phenomenon continues to be industrially used in today's society as a method of illuminating advertisements for the viewing public.
Thank you, science.